Target 8.2. I can convert among the following quantities of a substance: mass to number of moles, number of particles, or molar volume at STP. First I'm going to concentrate on mass to moles and moles to mass. Then we'll move on. Sample problem. How many grams are there in 4.6 moles of calcium hydroxide? The first task is to find the molar mass. In other words, I need to know how many grams there are in 1 mole of calcium hydroxide. By definition, molar mass is the mass of 1 mole. To find this information, we look at the periodic table and the formula. How many calciums are there in this formula? 1. 1 calcium. And we look at the periodic table under calcium and we see the number 40. It's 40 point something, but I'm going to round it to 40. 1 calcium atom has a mass of 40 grams. How many oxygens are there? This 2 tells you that there are 2 oxygens in every formula unit. So we'll put a 2 oxygens. We'll look at the periodic table and it's 15.99, so I'll round that to 16 grams. And then there are also 2 hydrogen atoms in 1 formula unit. So 2 H's. If you look at the periodic table, hydrogen has a mass of 1 gram. If we multiply across, we get 40, 32, and 2, which comes out to 74 grams. 74 grams in 1 mole of calcium hydroxide. What I've learned from that is 1 mole of calcium hydroxide has a mass of 74 grams. Now that I know the mass of 1 mole, all I need to do is calculate what the mass of 4.6 moles would be. But I want you to use conversion factors in order to do that. The first step here is always to write down your given. 4.6 moles of calcium hydroxide, and use this as a conversion factor. I want to change to grams, so I'm going to put 74 on top. 74 grams of calcium hydroxide in 1 mole of calcium hydroxide. Moles of calcium hydroxide cancel, and if you multiply, you get about 341 grams calcium hydroxide. Now let's do the reverse of that. How many moles are there in 200 grams of magnesium chloride? Before we change from moles to grams, or from grams to moles, we need to know how many grams are in 1 mole. 1 mole of magnesium chloride is equal to how many grams? That's, in other words, that's the molar mass. So we look at the formula of magnesium chloride and we see that there is just 1 magnesium. Look at the periodic table for magnesium and see that it is 24.3 grams. Then we see that there are 2 chlorine ions. If we look at the periodic table under chlorine, we will see that each chlorine is 35.5 grams. So we multiply across, we will get 24.3 and 71. Add that together, 95.3 grams. There are 95.3 grams in 1 mole of magnesium chloride. Now that I know this fact, I can use that as a conversion factor. I'll write down my given, which is 200 grams of magnesium chloride. Use this as a conversion factor, and since I want grams to cancel, I'm going to put grams down here. And And in 1 mole, that's what I want to go to, so I'll put moles on top. In 1 mole of magnesium chloride, there are 95.3 grams magnesium chloride. Grams magnesium chloride cancel, so now I just have to do the math. Divide 200 by 95.3 and you get 2.098 moles of magnesium chloride. Now your turn. Try this sample problem. How many grams are there in 3.75 moles of H2O? Hit pause and try this problem. And then I'll work it out for you. And if you picked C, then you were correct. Now that we know how to go from mass to number of moles and moles to mass, now we'll focus on number of moles to number of particles. Moles to particles. When we say particles, we're talking about atoms, molecules, or formula units. Any of those 3 words will fit into the particle slot here. What you need to know is that 1 mole, by definition, 1 mole of anything is equal to 6.02 times 10 to the 23rd. Whether you're talking about atoms, molecules, or formula units, we'll call all of those particles. Since we know this fact, we can use this as a conversion factor and make it cancel out the unit that we want to go away from. Example number 1, how many atoms are there in 2.4 moles of calcium? First step is always to write down your given, so I'll write down my given right here, 2.4 moles of calcium. And then I'll use this conversion factor, and since I have moles right here, then I want mole on bottom. And in front of mole we have 1, so 1 mole contains 6.02 times 10 to the 23rd atoms of calcium. So when you do the math, the moles cancel, and you end up with 1.44 times 10 to the 24th atoms of calcium. There is a moles to atoms problem. Now let's work the reverse. We'll still use the same conversion factor, we'll just have it flipped upside down. Problem 3. How many moles are contained in 3.8 times 10 to the 24th formula units of calcium hydroxide? We'll write down our given. Now, since particles can be atoms, molecules, or formula units, I have formula units here, so I need formula units down here so that it cancels. And in front of formula units, we're always going to have this number, 6.02 times 10 to the 23rd. In 1 mole of anything, there are 6.02 times 10 to the 23rd formula units, if we're talking about an ionic compound. In this case, we happen to be talking about calcium hydroxide. Formula units cancel, and so this shows us that we are going to multiply by 1 and then divide by 6.02 times 10 to the 23rd. Now be careful here. When you punch this into your calculator, if you use times 10 and the caret button, then you have to put this whole thing in parentheses. If you don't, your answer will not come out right. Go ahead and try it on your calculator right now. Now, if you don't want to have to worry about putting this number in parentheses, if you don't want to have to remember that, then when you punch this in your calculator, if you do it this way, then you don't have to worry about that. You hit 6.02 and then do not hit the times button, just hit the EE button on your calculator one time. Do not hit times 10. And then put your exponent in, 23. So you punch in this number first, then hit divided by 6.02, hit the EE button, and then 23. And you should get 6.31. Try that, see if you know. clicker check. See if you can get the right answer here. How many formula units are there in 3.45 moles of aluminum chloride? Go ahead and hit your pause button and try this, because I'm about to work it out. And this is the correct answer. Hopefully you got that. So this is our mole map, and this is what I've just shown you how to do. Notice that moles are in the middle. If you're given particles, for instance atoms, molecules, or formula units, and you want to go to moles, you use this conversion factor first, divide by 6.02 times 10 to the 23rd, then you're in moles, and then you will use this conversion factor, multiply by your molar mass, and that will get you into grams. If you're given grams and asked to go to particles, atoms, molecules, or formula units, you will divide by the molar mass. Now remember this number you get from the periodic table, that will get you into moles, and then multiply by 6.02 times 10 to the 23rd. Just follow the arrows. Notice moles are in the middle. You have to go to moles to get between particles and formula units, or particles and grams. You always have to go to moles first. Now let's try one of those problems where we put the two steps that we just learned together. How many formula units are in 60 grams of aluminum bromide? Write down our given. First of all, we have to write the formula for aluminum bromide. Remember to do that. Write your element symbol and its charge. And then you cross over the charges, so the formula is AlBr3. Now I have to get rid of grams because grams are here, so I want to put grams on bottom, but I have to know how many grams there are in 1 mole. You're always going to go to mole here. If you're not given moles, 1 mole will 3 bromines times 80, 79 point something, we'll round that to 80. So the molar mass of aluminum bromide is 267. That cancels our grams. Now I want to get rid of moles because I'm going all the way to formula units. So I need to put 1 mole down here, and I know that 1 mole of anything contains 6.02 times 10 to the 23rd particles. In this case we're talking about formula units. Now I just have to do the math. 60 times 1 times 6.02 times 10 to the 23rd divided by 267. Try that and see if you do not get 1.3 times 10 to the 23rd. 1.35 times 10 to the 23rd formula units. Remember to cancel everything. When you're finished with one of these problems, every single unit should cancel except the unit that you're asked for in the problem. Now that we've done that, let's do example number 6, particles to grams. What is the mass of 5.7 times 10 to the 20th molecules of water? First step is always to write down your given. 5.7 times 10 to the 20th molecules of water. The first step, if you're not given moles, is always to go to moles. So I want to put 1 mole here because that's where I want to go. In 1 mole of water, I need to know how many molecules there are. And there are 6.02 times 10 to the 23rd molecules of water in 1 mole of water. Now that I'm in moles, I can cancel out my molecules. I'm in moles now. It asked me to go to mass, so I need 1 more step. I'm going to put grams on top now, and I'll put 1 mole on bottom. In 1 mole of water, there are 18 grams. How did I find that out? We did that earlier. Water has 2 hydrogens, and the hydrogen has a mass of 1 gram from the periodic table. There is 1 oxygen, and oxygen has a mass of 16 grams. 2 times 1 is 2. 1 times 16 is 16. Add that together and you get 18 grams. 18 grams and 1 mole of water. So I put that there. I can cancel out my moles. The only unit left is grams, which is the unit that I have been asked for, mass. Multiply 5.7 times 10 to the 20th times 18, divided by 6.02 times 10 to the 23rd, and you should get 0.017 grams of H2O. Now the last part of this, I can convert among the following quantities. This time we're going to focus on molar volume at STP. The capital letters STP. What that means is standard temperature and pressure. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere. Later in the year we'll learn about different pressure units. But for now, you just need to know that standard temperature and pressure is 0 degrees and 1 atmosphere. Any gas at STP has a volume of 22.4 liters. 1 mole of any gas has a volume of 22.4 liters. It doesn't matter what the gas is. If it is at 0 degrees and 1 atmosphere of pressure, then it will take up a volume of 22.4 liters. Because you know this, you can use this as a conversion factor as long as we're at STP. And for now, all of our problems will be at STP. We'll use this just like we used 1 mole is equal to 6.02 times 10 to the 23rd. An example might be grams to liters. What volume would 75 grams of carbon dioxide occupy at STP? Well, the first thing we'll have to do is change 75 grams of carbon dioxide to moles. Once we get it into moles, we know that 1 mole occupies 22.4 liters. So we're going to go from grams to moles to liters. First step is to write down our given. I'll write down 75 grams of carbon dioxide. I want to go to moles, so I want to put 1 mole here and grams of carbon dioxide there. I need to know how many grams are in 1 mole of carbon dioxide. In other words, I need the molar mass of carbon dioxide. There are 2 oxygens, and oxygen has a mass of 16, so 2 times 16 equals 32. There's 1 carbon, which has a mass of 12, so 32 plus 12 gives us 44. So 1 mole of carbon dioxide has a mass of 44 grams. I can cancel out my grams. Now that I'm in moles of carbon dioxide, I will use this conversion factor. I will put 1 mole on bottom to cancel out with 1 mole here. And I know that 1 mole has a volume of 22.4 liters as long as we are at STP. Since these are equal, I can multiply by them. Cancel our moles. 75 times 22.4 divided by 44 gives us 38.2 liters carbon dioxide. So now we add to our diagram showing liters. Notice that moles is central. If I want to go from liters to particles, I will go use this conversion factor to get me to moles, and then follow this arrow, use this conversion factor to get to particles. If I want to go from particles to moles, use this conversion factor to get to moles, and then from moles to liters, use this conversion factor. So this is kind of a mole map. Notice that moles are in the middle. If you're not given moles, you always need to go to moles first to get where you're going.